Hello, this is Diane Dalton. We're going to continue in Chapter 5 of our textbook on database design. This is the first chapter on design topics, and it's on normalization. So this is really kind of switching gears, because we've been working with several databases so far, and these databases were already designed and existed for us. We're going to really talk about now the process of coming to that design, and by design we mean which tables we have, what are they named, and what fields are in each table, and then how are the tables related to each other. So the design is a process that you go through to get your database into a good condition so that you don't have data redundancy where you're going to have update issues. If you save data in one place, you don't need to save it in multiple places. So we're going to go through how these tables were designed, focusing on the Premier database. So in this lecture we're going to talk about two definitions, functional dependence and primary keys, and then we're going to go on and describe these normal forms. There's first normal form, second normal form, third normal form, and fourth. And these are different levels of design phases that help us get our tables into the right structure for a good database. We're also going to talk about some of the problems you might have if your tables are not normalized, and we'll understand why normalization is so important in the design process. So what is functional dependence? It's a lot of words, but it basically means that one field depends on another. So if you're in a database, it means one column depends on another field. So if you take, for example, the rep table that you've looked at before in the Premier database, and ask yourself this question: if you know the rep number, is there only one value for last name? In this case, yes. You know that if you get one rep number, there's only going to be one last name that matches that. But if you ask it in the other direction, if you have the last name, is there only one value for rep number? No, because you could have two reps with the same last name, but they're different employees. They just happen to have the same last name, so it's not dependent in the other way. And the notation that's used to say is that A determines B, or that B is functionally dependent on A. So if you know A, you can find B. So here's our rep table that we're familiar with, right? We have our rep numbers, we have last names, all right, all of this other information about the rep. So if you know rep number 35, if you're looking for that, can you find one last name associated with 35? Yes, there will be only one. Okay, let's look at it the other way. And this table has one more person added to it that wasn't there before. And this happens to be another person named Will Kaiser. Different first name, but same last name as somebody else that exists. Right, so if you had the last name Kaiser, could you pick out which rep number it is? No, because you might get 20 or you might get 85. Another term is keys. And we've been using the term primary key, so I think you understand this. Column A is the primary key for a table if all columns are functionally dependent on A, and that there's no subcollection of columns in A that also have the same property. Right, so what does that mean? Alright, so any other candidate key is something for which all the columns in the table are also functionally dependent. Alternate keys are keys that were not chosen as the primary key, but could have been. In our rep table, all of the fields are functionally dependent on the rep number. Likewise, if your rep table included a social security number, that would also be a unique number for each person, so that could be an alternate key. So everything would be dependent on that as well. Now let's talk about normalization. Normalization really is just a process, stepping through and identifying potential problems and getting rid of them in our design. Our problems are what can cause update anomalies, which means when you're trying to update data, you might not get all of the data updated at the same time. So we have to get rid of those cases in our design so that our database is more stable and accurate. So during the process of normalization, your tables take on different forms. Okay, we call them first normal form, second normal form, third normal form, and fourth. And it's a progression. Okay, so we're going through this process. First normal form, we're starting. We're just getting a little better. Then we get better. Third normal form, Some databases are done at this point. You don't have to go any farther. It's taken care of all of the problems by this point. But if you go through the fourth normal form and have to correct some design issues from the third normal form, then you're in good shape. You've got a good design. Alright, so what is first normal form? Each one of these forms has a definition that says we've taken care of a certain amount of problems. So what is it in first normal form? It means the table does not contain repeating groups. Okay, well, what is that? And the reality here is most modern databases, including SQL Server, don't even allow this to happen. So what would a repeating group look like? If you had an order form and you had an order number, an order date, but you had multiple parts on it, okay, that's a repeating group. Okay, it's like having two rows associated with one record. Databases don't allow that anymore. Okay, so that would have been a bad table, unnormalized. So how is it when it's normalized? Well, what you do is you repeat the order number and the date for each of these. And now for the key on this table, it really becomes a combination of two fields. Everything else in this table is dependent on combination of these two fields. Now when we go to look at second normal form, we start to look for things where we've got data in multiple places. Okay, so here's an orders list. We've got our order number, our date, our part number, and if we have the description in here as well, and how many were ordered, and what was the quoted price. Now what do we have here? We show that our gas range, the text for it, is listed here, as well as here. The problem with having the same description in two different places is, what if we go back and change the model or the description of this and say gas range with built-in hood? Okay, so suppose you needed to change that. Do you have to change it in every existing order? Everything that's been written before? So that's the problem. There's too many places where you would have to go back and change that data. So what second normal form is, so you want you to look at the functional dependencies. So here, order date is dependent on order number. Description is dependent on part number. Number ordered, quoted price, order date, and description are all dependent on this combination. So what the second normal form process wants you to do is to separate these and get rid of any time that you have redundancy, where you've got data repeated in multiple places. Why? Because redundant data is bad. It wastes space, for one thing, but also if you change data in one record and not in all of them, your data is inconsistent. Which gas range was it? If they have different descriptions, did it mean the same part number? Alright, so think about it. If you added a new part in that table, do you need to have an order before you can have the new part in your inventory? What about deleting a part? You stop selling it. Do you have to delete the record of every past sale because you no longer have that part? Those are the reasons why you want to get to second normal form. Those would cause update anomalies. Anomalies are things that are inconsistent. So let's see how that works. Here we're introducing this dependency diagram where we had this list of columns. That was from this example. Those were our columns. And what we're doing is we're showing the dependencies. Alright, so order date, it's hard to read this, but it's dependent on order num and part num. Then description. Right, so as you see, description is dependent on both order num and part num. Num ordered is also dependent on order num and part num, as well as quoted price. But description here is also only dependent on part num. Order date is only dependent on order num. So when you get into your second normal form, you're identifying your dependencies. Alright, so you want to separate into different tables such that your description only depends on one thing. So when you look at this, all of these other fields depend on a combination of the order num and the part num, but description depends only on part num, and order date depends only on order num. So those are two fields that we want to pull out and put into separate tables. And here's how it looks like. This would be your original table, not in second normal form. what we're going to do is split that into 3 tables. So we're going to have an orders table, we're going to have a part table, and then an order line. Alright, so this is starting to resemble much more like the database that you have been working with, where we have an orders. So we have the order and the order date, because the date depends only on the order number. Then we have our part table, so we have our part number and our part description. Alright, so we've pulled that description part out of this table and put it into a separate one. Likewise, the order line, now this one does have 2 columns that make up your primary key, and so the number ordered and the quoted price depend on the combination of these. So that's second normal form. Alright, so we're going to keep improving our database design. Second normal form got rid of some problems, but there can still be other problems. So if you look at a customer table that has this sort of a definition, okay, customer number, your name, balance, credit limit, rep, last name, and first name. Right, so where are your functional dependencies? The thing is here, if you've got rep num and you've got last name and first name, that means you're repeating this last name and first name on every record where rep num is used, where that particular rep is used. If you want to put this into third normal form, what you're doing again is you're looking at dependencies. All of these things depend on customer num, but you can see that last num and first name are functionally dependent also on rep num. First and last name, it's dependent on rep num. So the right way to do that, again, is to avoid anomalies. We're going to find where something is a determinant, as in it determines another column, but it's not the primary key. So rep num is not our primary key in the customer database, so we want to pull it out of there, pull that dependency out where we have rep num is the determinant for last name and first name, and we're going to pull that out. So for each determinant that is not a candidate key, because all the other fields are not dependent on rep num, we're going to remove that table from the column, create a new table that has some of those original columns, in this case last name, first name, and the rep num, and we're going to make that determinant, the rep num, is going to be the primary key. So what we're doing is we're taking the last name and first name from that customer table, because those are dependent on rep num, but rep num is not the primary key for this table. So we're taking those 2 columns out, we're going to put them into a separate table where rep num now is the primary key for this table, and these are your dependent fields. And then in customer table, we're only going to refer to rep num, which will then point us to where we can find last name and first name. So that's third normal form. Right, now let's look at what can go wrong when you're doing this. So you're decomposing your table the way we've described as your third normal form method. But sometimes you can do this incorrectly. Let's see at some of these mistakes that might happen. Alright, so here what you've tried to do is to take this same table. Now nothing's changed here, right? We've got our rep numbers and our last name and first name all in that table. What if you take it and split it up like this and divide it by customer num and put last name and first name? Well, that's not really the rep num. That's not indicating the rep number. So you don't want to do it that way. Now here's another different way to make a mistake. Again, back to the original table with our last name and first name in there. Well, this is okay for your rep num table. That looks fine. But you're still leaving last name and first name in here. Alright, so you're repeating that data. Okay, better to use the index. You want to use what becomes the primary key in the new table as the indicator or the field value in the customer table. Now, after third normal form, we still might not be done. There could be problems. Let's go on. So as we continue beyond third normal form, the next problem is multi-valued dependencies, and we're trying to get to fourth normal form, because your third normal form might still have some problems when you're making updates, additions, and deletions. Alright, so there's a lot of words here and definitions of B is multi-dependent on A multi-determines B. Okay, so those are some definitions. Still kind of confusing. Again, here's the formal definition. Table is in fourth normal form if it was in third normal form and has no multi-valued dependencies. So what do? Again, you're going to convert things into separate tables, each containing columns that determine the others. It's really much easier to see with an example. So let's continue. Here's a multi-valued form. Now this is using a college example where you have faculty members and they advise multiple students. Well, that same faculty member might be part of multiple committees, and each of those committees has a code. So if you have a faculty table and it lists what students you have and it lists what committee that faculty member is on, you could have that all in a table. But what happens is you've got the faculty number listed here, 6 times, the same person. You got multiple times that you're listing the same student just so you can get every one of your committees listed. Well, these things aren't really related. What students they advise is not really related to what committee that faculty member sits on. Right? So that's trying to have too many multiple values in the same table. So what you want to do is split this out and have your faculty number, and it can be identified as with multiple students, and likewise that faculty number can be associated with multiple committees. Okay, so that splits it into separate tables, gets you in fourth normal form. So in general, here's some of the summaries. In first normal form, you have no repeating groups. Again, Access and SQL Server don't even allow you to put things in like this, where you could have multiple lines within one record. Second normal form, first you have to get the first normal form first, and then you have no non-key column that's dependent on only a portion of your primary key. Third normal form means you've gotten to second normal, and the only determinants are your candidate keys. Okay, and then third normal form, and when you get rid of all your multi-valued dependencies, you're at fourth normal form. So that's the process of getting your tables into fourth normal form. So how do you do this? Of course, what you want to do is carefully convert your tables to third normal form, go through and review all of your assumptions, all your dependencies. You want to remove any kind of interrelation constraints. Those are things that involve 2 or more relations in one table. So remember, the faculty-student table means you don't put in the committee codes in the same faculty-student. So in summary, we looked at functional dependence. That shows that one field is dependent on another. A primary key is the primary key if it's all the other columns are functionally dependent on that, and a candidate key is where there's more than one choice for your primary key, but it is not being used as the primary key. So in summary, we had the normal forms 1, 2, 3, and 4, and the goal here is to get a good table design so that you do not have mistakes when you're updating your data.